Action.
Hey guys, this is question 3 on the worksheets I've given you. Okay, now this is another one that's definitely going to be on the test. But let's go over this one, right? So I believe when they ask this, I'm just going to drop off here. F1 and F2 are 100 amp fuses. First thing they ask you to figure out is, given the situation as it is, which fuse will blow. So we got to get some currents. So if we come right here, a voltmeter right here and here, bang, bang, we got 240 volts. 240 volts over 3 ohms will cause 80 amps to flow. 120 volts here, if we look right here, 120 volts over 6 ohms will cause 20 amps to flow. 120 volts over 4 ohms will cause 30 amps to flow. So if we use Gustav Kirchhoff, come into this node right here, 80 and 30 means I've got 110 amps on fuse 2. And if we come back over here, leaving this node is 20 and 80, I've got 100 amps on fuse 1. So I say, right, with given that information, that sucker's going to blow given enough time. Okay? So fuse 2 will blow. And that's all we needed this Ohm's law for, was to figure out the current. Now it's gone. Now just like in that last one I was talking about, I've got now 120 volts here, okay? And I've got it, nothing changes in 6, right? We had 120 volts before fuse A blew, and then we still have 120 volts after fuse A blew. But here's where it changes. Top of 3 and 4 are in series over 120 volts. Okay? So this is going to be 20 amps, right? 3 and 4 is an R total of that branch of 7 ohms. 7 ohms divided into 120 volts causes 17 and change amps to flow. So coming out of here is 17.14 amps. Goes down through there, comes down through there, goes up through here, and goes home. Okay? So, I like that. Let's do some voltage drops. I'll get a different colored pen. So as we go right here, you guys, the voltage drop over this one is going to be 120 volts. Agreed? The voltage drop over 3 is going to be 17.14 amps multiplied by 3 is 51 sorry, my memory's not so good, 43 volts. And then that 17 amps comes in here. 17 amps over 4 ohms is going to cause 69 amps, 69 volts drop. Ish, right? We left it alone. I like all that stuff. The voltage over here, we can do later. Now let's have a look, you guys. Let's have a look at which voltmeter. If I take a voltmeter, and this is a live circuit, and I go to the hot side of fuse 2, and I go to the hot side of fuse 1, they're calling that voltmeter 1. I'm still expecting to read 240 volts.
Which worksheet?
So voltage 1 is 240 volts. And if you look at the worksheet, you guys, so that's V1. Okay? V2 goes from here to the other side of that fuse. Now, an unblown fuse is like a piece of wire. It's the same potential all the way across. So V2, if we take a voltmeter right here and we slid it down there, we're not going over any resistive device. It's going to be the same as V1. V2 is going to be 240 volts. Now, if we look where V3 is the exact opposite. To the one side of a blown fuse, there's a voltage there. It's not going to read 240 volts. But let's slide this to this side. It's going to do the same because that's a wire. Let's slide it all the way back, all the way back. V3 is just going to read the voltage drop over the 3 ohm resistor, which is 51.43. Okay? Now V4, where did they put V4? That's an ugly one. Right there. What's the voltage over there? Now, Gustav says the voltage drops in any closed loop is equal to the voltage rise. I've got a 240 volt rise. 0 voltage drop over that fuse. 51.43 voltage drop over that fuse. Plus whatever this voltage is has to equal 240. 240 minus 51.43 will equal 188.57. Okay? I like it. There's V4. That's over the open fuse. And if you just keep it simple like that, it gets easier. V5 is right here. So if I had a piece of conductor, let's say this was a piece of conductor and I took a voltmeter and I put it here and I put a voltmeter there, it would read jack schmack, right? It wouldn't read anything because you got no resistive device in there. It's a solid piece of wire. V5 would read 0 volts because we're not heating. Okay? V6, then let's look where V6 is. V6 is right here. I'm going to come back here. V6, come down here to here. Okay? V6 is right there. If we follow V6 and V3, they're the same, and we follow it to its conclusion, V6 is just a 51 over R3. V7, where did they put V7? Over this one. What was my voltage drop over that resistor? 69, actually 69.64. V8, where did they put that bad V8? Over this one. So V8, oh that's not V8, that's V9. Sorry about that. This is V8. It gets a little hairy, you gotta keep track of it. The voltage over the 6 ohm resistor is just 120 volts. And then V8 then is over the 3 ohm resistor again, so there's 3 readings over this stupid resistor. Don't let that screw you up. It's still 51.43. There we go. So we've solved that entire equation. And I can guarantee you we're going to see one like that on the test, you guys. If you keep track of it, it's not bad. Now what I'm going to do is I'm going to let you go now. We can work on... Oh, Holder?
We've got some questions.
Okay, we've got some questions. Let's go.
Hang on a second here. The question is not to do with this, though. It's to do with something else.
Okay.
He's not being able to get his worksheets.
This is Kale. 1 second.
Kale, okay. Tell Kale I will email him the worksheets.
Okay.
Okay, have you got that, Kale?
I got to write this. Kale email.